All right, we have a very special presentation today. First of all, we are educating Alexis. Say hi, Alexis.
Hello.
And to meet her contractual obligations, we have our special guest star, Aubrey. Say hi, Aubrey.
Hi, Aubrey.
Hi, Aubrey.
Bruh.
So today we've already decided on the question because this is what's happening in our backyard. So today we're going to learn about
Snow.
snow. All right, so today's a special day. We have a ton of snow. It is
Like 7 degrees.
It says it is 7 degrees outside. It's pretty cold, especially for this time of year in Oklahoma. And so we're going to learn about snow. So first of all, Aubrey, do you know what snow is made out of?
I think I heard it was like water that like freezes a little bit.
It is water that freezes a little
It
bit.
is crystallized water.
So let's do a quick little search. Let's go precipitation and how snow is made. So precipitation is anytime we have stuff falling out of the sky, like water. And this is a very good example of why we don't have more snow in Oklahoma. If it will load. Loading. There we go. So a lot of times we actually have the conditions for snow a lot of times during the year, but hey, don't kick that. So we have the conditions for snow up in the upper atmosphere, and we have freezing temperatures down at the bottom.
We don't have warm in the middle.
Well, no, we do have warm in the middle. That is the problem. So if you'll see, so whenever there's a pocket of warm air that reaches all the way to the ground, you just get rain. So if there's any freezing precipitation up in the top of the clouds, they melt and it never refreezes.
Oh, now I see what you're saying.
Yes. So if there's a little bit smaller pocket of warm air and there's freezing air down by the ground, we get freezing rain. And we get this a lot.
Yeah.
And what happens is we have frozen precipitation up here in the top. It falls through the warm air and it melts. And then as it gets down to the colder air on the bottom,
it freezes a little bit again.
Well, it freezes as it's hitting a surface or immediately after it's hitting a surface. So that's when you get the sort of the ice that looks like it's coated around stuff. Let's see. See if we can find. Let's go. Ice coating tree branch.
Oh, that looks really cool when it happens, though.
Yeah, this stuff that's like where it's encrusted in ice. So that's a good one.
It looks really cool. It's cold, but it looks cool.
Yeah, you see how the ice is like it's coating it. It's like it was dipped in water over and over again and frozen.
Kind of like frost, but more solid.
Yeah, so that is what you get when you get freezing rain. Sleet is when we have just a little bit of warm air, and so this freezing precipitation melts, and then it freezes in the air again before it hits the ground. And so that's when you get like the pellets, you get the hard stuff hitting you. And that's the stuff that y'all don't like. Y'all don't like being in the barn whenever it's sleeting because when it starts hitting the tin, it sounds like.
It sounds really weird.
One time when it was
like a bunch of clumped up sleet.
One time when it was raining, it was not raining. It was just like sprinkling, and it sounded like a bunch of elephants was stomping on the roof.
It is. It's loud in the metal. Now you mentioned hail. Hail's not on here. Hail is a special case. That's whenever there's a strong. Let's go back here. Whenever there's a really strong updraft, so we've got a big, tall cloud. Like so, thunderstorm clouds are really tall. And so you have a little bit of water that freezes, and when it freezes, it gets heavier and it falls down, but there's really powerful updrafts that blow that back up, and so it gets water coated on the outside of it.
Oh my.
And then when it gets up here, it freezes again and it drops and it hits the updrafts, and it keeps doing these cycles
Until it's heavy enough to break through.
until it gets heavy enough to fall all the way through. And if you cut open hail, you'll actually see there'll be usually a little piece of dirt in the middle. Sometimes it's
Dirt.
big enough you can see it. It's a condensation nuclei. And then it'll have layers like an onion. And that's all the times that it got thrown back up into the top of the cloud.
It's an ice onion.
Yeah. So every time it goes up, so it goes up, and you get a layer of water gets coated onto the outside of it as it's going up through the cloud, and then it freezes into another layer and it falls back down, and then it gets blown up and it gets another layer of water on it, and then it freezes and then it falls down. So that's hail. It's a little bit different. The condition that we have right now that lets us have snow is that there is a column of cold air all the way from the clouds down to the surface. And that means that the snow will fall through completely and it won't melt and remelt. All right, so have you ever heard that no two snowflakes are alike?
Yeah.
All right,
You
so
hear that like all the time.
Yeah.
So snowflakes. So here's some pictures of some snowflakes. Now, the way that these particular snowflakes form is they start, let's see, what's a good color for snowflakes?
Blue.
Blue.
So it actually starts here, this crystal here at the very beginning. And it actually has little holes in the side of it because the ice freezes from the edge first and then it freezes last in the middle. Okay, so if we took a drink and we stuck it in our refrigerator, well, not in our refrigerator, if we stuck it in the freezer, if you looked at it, it would freeze. So if this is like the cup, it'll freeze on the edges towards the middle.
Oh yeah, I think I've seen something like that.
One,
And it'll freeze top down.
when it was snowing yesterday, a few days ago, the snow was so big you could actually see the snowflakes is falling.
I don't know about big. They were really small, but yeah, you could kind of see their shape.
So if it's cold and there's a lot of moisture and the wind is strong enough to sort of hold the snowflakes up, that's when you get the big, fat, really clear snowflakes. So it'll form, and it actually has sort of little cavities in this because it freezes from the edge first. And then what happens is you get these little knobbies pointing out because that's the part that froze first. And so it starts collecting more and more water. And then at different temperatures, they will start growing out and they start getting these little crystal protrusions and they just keep growing.
It keeps crystallizing as it falls because it's collecting more water.
Yes. So we should be able to see a cool little, all right. So this explains it. Oh man, that is not very clear. Let's look at this one.
There we go.
So yeah, we start out with just a piece of dust or grain, something that's a condensation nuclei. That is something for the water to condense on and start the process. And then as it freezes, see, a cavity forms in each prism face because the ice grows fastest near the edges. And then what happens is you start getting these little branches that are growing off. And whenever you get a little bit more water, it starts building up on the little edges that are sticking out. And this is saying that warmer air on the way down will cause long, narrow tips. If it's cold enough the whole way down, the flake will still be frozen when it reaches the surface. And so whenever you have warmer air, that's when you get more moisture building up on these little spikes that start protruding off the edge of the snow. And that's where you get these little crystal patterns. And see, they form at different temperatures, and you get all of these different temperatures in the cloud because at the top of the cloud it's colder than whenever the water is falling down through, and you're getting it gets warmer as it gets closer to the earth. Cool?
Yeah.
Yeah.
Why'd you sound? You had an interesting tone when you said that, Dillo.
Yeah. And so we will have this. It's actually cold enough. So have y'all heard the ground's not cold enough for the ice to stay or the snow to stay?
No.
No, you should have heard that because that happens all the time in our part of the world. So one of the reasons that sometimes we get snow and it doesn't last very long is the ground actually holds heat energy better than the air.
Well, that kind of makes sense.
So this ground is warmed up, and even if the air is cold enough to get snow to fall on it, it will pile up for a short amount of time, but then it melts off really quickly. But in this particular case, it's been cold enough for
Like a week.
yeah, it's been cold enough that the ground is going to be cold enough that the snow's probably going to stick around for a while.
Really?
Yeah,
Yeah.
but we have to do online school instead of getting a snow day, which is not cool. It's not
Yeah,
cool.
well, it's the wonders of technology. So,
Plus the technology, and we're sending a packet home.
so you're all excited that we've got snow to look at, though?
Yes.
I'm just glad we have snow to play in.
All
well,
right.
it's a bit wild right now, but when it gets calmer, I will pummel you with snowballs.
No, thank you.
All right, girls. Good job.